and then here they're gonna what? They're gonna present it in a what? In another structure, and then whereby you are going to get or is going to cause the rotation. And then if you can check this structure, especially here at this carbon, the first carbon, I think they're the same, right? So but let's check at this second carbon. Now the hydrogen atoms have changed the positioning or the direction. If you can check this one and also this one, the positioning are not the same. So it means that here there was a rotation which took place, just like here at the first structure there, whereby at carbon number 2, you had an impact of the rotation in this carbon atom. You see the hydrogen atoms, they are now in another form of position. Yeah? So under the conformational isomers, right, because we're still on the conformational isomers, we are going to represent them in two ways. They can ask you in terms of the conformational isomers, you must write the structure in a Newman projection, or you must write a structure in a what? In a seesaw. This is a seesaw structure. Whatever this you were seeing here, this is an example of a seesaw structure. I mean a seahorse structure, not a seesaw, a seahorse structure, right? So they can ask you either in the form of the Newman projection formula or in a seahorse projection formula. So it's very much important for you to know that when we're talking about a Newman projection, we're talking about this, whereby you are going to look at your attachments of the hydrogen, I mean the carbon atoms. They will tell you, or they will specify that looking at carbon which number which, because remember, let's say we are having something like hexane. At hexane, we're having 6 carbons, right? You're going to draw your normal structure. Okay, then they're saying that looking at structure what? Looking at carbon number 4 and 5, meaning we're going to focus on carbon number 4 and 5, right? So that will be an example of a Newman projection. Can you see here? A Newman projection, it visualizes the what? The different conformation of the carbon-carbon chemical bond from the front. You must know that when we're talking about the front carbon, which carbon are they talking about? And it represented by FC or the BC. When they're talking about the FC, you must know that this is the front carbon. When they're saying that this is the BC, you must know that this is the back carbon. Okay, so I want to look for that example or that yes. So can you see this person looking at the structure? The perspective of drawing, when you draw it, you are drawing it like this, but when you are going to look at it, it's not the same as the way you are going to draw it, because when you're drawing it, you just draw it on a piece of paper. You just draw it the way you present it on the paper, because you don't usually view it in the side way. Okay, so if you can check the way we are drawing as our Newman projection, we are just looking, maybe when you are standing and then you are looking straight to someone there. So this is in this case, that's how we are going to view a structure. You are no longer going to view a structure like the way you draw it or the way you write it down. Okay, because here we want to easily identify our front carbon, which is in front of your eyes, right? Then after, it will be the what? The back carbon that will come after the front carbon. So that will be the BC, which is the back carbon. Okay. and then you'll be able to draw your structure depending on what they have told you to draw or what um, to present. So how to draw the conformation Newman projections? You must first draw the front carbons with the attached hydrogens. Meaning here in this, you see this center here. This center, they represent the front carbon. And you know that you cannot draw a carbon without a hydrogen. Carbon will always attach to the hydrogen atoms, right? So those H will represent your attachments towards the carbon atom. So that's why we're having 3 of them, because this will represent your front carbon, right? So now that the back carbons are added as the second and they are attached, meaning after you have entered your front carbon, the front carbon is represented by this one, right? These 3 red lines. In the middle is carbon, okay? And then the circle which will come after, or which will close this, actually not necessarily closing them, but which will cover these 3 red lines, it will be your back carbon. This circle, the whole this circle, it is your back carbon. One carbon only. This circle will represent a back carbon. So thereafter, you are going to also what? Attach the hydrogens which are next to that carbon, or which are attached to that particular carbon atom. Just like this one. We said that our carbon atom is in the middle, in the center here, and then it is attached to what? To the 3 hydrogen atoms. You see them. So this one they are saying that it is an eclipsed structure. So after it has been eclipsed like this, we're going to have the rotation. Okay. Then after encountering the rotation, our structure will now change. But we focus mainly on the what? On the back carbon. We only rotate the hydrogens on the back carbon. Okay. If you can check now, our hydrogen has been rotated. Our hydrogen atoms is now being rotated. So this hydrogen, if you can check now, it has been this side. Then here it will change, and then it will go this side. So this one will go in the middle, then it will come here this side. So in this case, that calling it as the what? As the staggered, staggered structure. Ne? So they are saying that the eclipse structure, it will be less stable, and then the staggered structure will be more stable. This question, they like it a lot. Most of the questions of the question papers, they really ask it, because they usually give the structures like this and then ask you between the eclipse and the staggered, which one is more stable or which one is less stable. Or they can give you a structure, which one is more eclipsed or which one is staggered. So it's very much important to know your the different rotations that they are going to give you. So this is what I'm talking about. I've told you in the middle or in the center here, we're having a carbon, which is it represents the front carbon. Then this circle, it will represent your whole of what? Of your back carbon. Then here is the sawhorse presentation. Representation of the structure. So if you can check here, we're having the, yes, you see this one. Let me try to present something. Okay, I see a message here in the chat box because the person is asking that why the staggered, why is the what? Oh, why is the staggered structure more stable than the eclipsed structure? This is because of the angles. Actually, the angles between the carbons and the hydrogens. If we are saying something that is stable, meaning we say that it is more rigid, right? It can afford to, if we were talking in terms of physics, it can support the structure of something. It is more stable, right? It can be able to provide or to minimize the energy. So look at their structures, the way they are arranged. Let's say, let me go to that. Yeah. Look at this eclipse structure. Do you see the hydrogen is this side, the other hydrogen is this side, the other one, like the way they are not. But if you can check this one in the red ones, the hydrogens, the way they are arranged in a proper way, whereby they are more stable. But because of the back carbon, which has caused another motion or another different format here, we're having a different thing, because now they are no longer more stable. But after we have the rotation, do you see now your hydrogen are arranged in such a way that they are more stable? This side, this side. Actually, I can say that if we were talking in terms of a building, my building is more balanced. I don't know, you get my point. Because if you can check this red structure, your hydrogen are arranged in a way that they are more stable. They can support this carbon atom in the middle. But here, the other hydrogen is there at the top. This one is here a little bit below the carbon atom, and then this one. So when we're having a rotation, um, it's gonna support your structure now, because the way they are arranged. That's why I'm saying that if we're talking in terms of physics, we would say that this structure is more rigid and can be able to minimize the energy. Yes, thank you. Um, so do you see this one? Okay, let me try to project something so that maybe we can do this one together. Maybe you can understand. Okay, they said that you must draw the structure looking at propane. Oh, let me check which carbon number. Oh, drawing a new projection for propane looking at carbon number 1 and 2. So when you're going to draw your Newman projection, you're going to focus on carbon number 1 and carbon number 2, right? Okay, we firstly draw the structure of propane, the normal structure that you know. It's C, then C, then C, right? Then your carbons. I'm not gonna indicate those carbons. You know that these lines, they represent the carbons because of time, right? Carbons, carbon, carbon, then the carbon, and also the carbon. Yeah. So this is our propane. We're having 3 carbon atoms. Okay. Yes. So when we're going to draw our, firstly you must draw your what? Your eclipse structure. Okay. Yes, am I breaking? Am I breaking, or is it only from the other side? Guys, I've asked a question whether I'm breaking or is it only for the side, so that I can continue, because I cannot continue if maybe there's a problem on my side.
You were breaking, now you are fine.
Okay. So I said that we are going to draw our, now we're going to draw our eclipse, right? They said we must focus on carbon number what? On carbon number, let me try to use the different color. On carbon number 1 and carbon number 2. So apparently this carbon number 1, which is C1, C1 will be what? Will represent your FC. Your FC is what? Your FC is the front carbon. Né? Then carbon number 2, which is C2, then it will represent your back carbon. Remember, on how are you going to view your structure? Your structure, you're going to view it on this, from this side. Né? Then your carbon number 1, it will be your front, because it will be in front of your eyes. That's why we are saying it is the front carbon. Then this one is the second carbon, which is C2, it will be your back carbon. Then when we're going to draw our, we're going to start with this portion, right? We focus only on this portion. Okay. Then this is the dot in the middle. It represents this carbon, okay? Then we are going to say 1. For the hydrogen, for the first hydrogen, remember it is attached to 3 hydrogen. Then another one, which is 2, will come here. Then we say 3. So meaning we are done with the front carbon. Then we represent it by H, by H, by H here, and also your H here. Okay, and then meaning we are done with the what? With the front carbon. Maybe I can erase it so that you don't get confused. Meaning I erase this part. This part I erase it, right? So now we're going to have the second carbon. This is the second carbon, okay? Our second carbon, you're gonna represent it in as the what? As that second. your back carbon. We're gonna draw a circle here. So this is your back carbon. Okay, it is represented by this guys, where did I stop? Because I lost connectivity lately. I noticed that I lost connectivity. Where did you? I mean, where did I stop actually? Ash, and this will need me to start again. Guys, I must do it audible enough so that we can wrap up.
Yeah, you're audible.
Okay, so I have drawn the structure now. I mean I have to redraw it again, but it's not a problem. So it was like this. It was like this, and then here we had hydrogen. You forgive this and the writing here because this the mouse doesn't write very well on this board. So we were having C, we were left with C. Then here was another hydrogen. Then attached to the carbon number 3 because it was propane. Then 1, then 2, then 3. Right? Then I said that this carbon number 2 is going to be represented as the back carbon. Then it will be more like a circle like this. It will be a circle like this. Then it will represent your carbon number 2. Then the carbon number 2 is attached to what? To the hydrogen. Meaning you must draw that, you must, along the side, you must include that hydrogen, the first hydrogen. Then even here, we must also include that hydrogen. But we are not done. Everything which is attached to this carbon must be included. So now we are left with this part. This part, we're going to include it here. Meaning it's what? It's C, it's more like a branch. It's C, 1, 2, 3, meaning it's going to be CH3. Then we're going to write CH 3. Okay, so this will be your what? This will be your staggered structure. But when you're going to do your eclipse, remember my eclipse should now be more stable because this one was eclipsed. I mean your staggered should be more stable as compared to the eclipsed. So this one is okay. We are going to draw it the way it is. Then the circle, which is the carbon number 2. Sorry. Then when we're going to draw your stapled one, we're going to put hydrogen here, then another one here, then below, you see now it's more balanced or more stable. Then here is going to be your CH3 again, your CH3. Then here we're having the H, this is the hydrogen. Then we're also having the hydrogen. So this structure will be what? Will be your staggered structure. Then this one will be your eclipse structure. Then this one will be less stable, whereas this one will be more stable. You understand? You guys understand? You see this example? This is what I was talking about. Same applies to this one with butane. Butane it is having how many carbons? It is having 4 carbons, right? Your structure mean is going to be 4 carbons. Then after, you're going to look at carbon number 2 and carbon number 3. Add carbon number 1 and add carbon number 2. I mean, add carbon number 2 and add carbon number 3. So since we're starting at carbon number 2, it's not like you should leave out carbon number 1. Anything which is going to be attached to carbon number 2, you must include it. Remember, carbon number 2, it will be your front carbon, right? So meaning it's going to be attached to the backward carbon number 1. I mean carbon number 1, not the backward. So carbon number 3, which will be your back carbon, will also be attached to carbon number 4, because butane it has 4 carbons. So you're gonna draw this. You see this one. See the carbon number 2 is gonna be this one. We're gonna represent it in the middle. You see, it is attached to what? CH3, right? So here is gonna be CH3 because it is attached to carbon number 2, and it is in the middle. And then the hydrogens, which are 2, is 1 and 2. And then moving to this one, they said that, and looking at carbon number 3 also, which is C3. Né? C3, which is 1, 2, it has how many carbons? It has 3 carbons, which is 1, 2. Again, it is attached to what? To the CH3. You see, then you write your CH3 here. So this one, they are saying that it is anti-staggered. This one is anti-staggered. And then we're also having the word the gauge. The gauge staggered. The gauge staggered, the only difference is that they have rotated to whatever this functional group, and then they have imposed it this side, or they have rotated it to this side next to this one. You see, so that they're saying that it's a gauge staggered Newman projection, and then this one is the anti-staggered structure. Okay, so these are just the seahorses structures for butane, together with what we already discussed, which is your Newman projection structure. Same applies to ethane. Here they're just giving you the examples. The eclipsed and the staggered. We're also having the hexane. They're saying that you must look through carbon number 3 and carbon number 4. So whatever that you're going to draw, meaning at carbon number 4, which is attached to everything that is at the back, which is 1 and 2, we're going to include it. So meaning is going to be C2. Yes, C2. Because we're having 2 carbons, right? So everything that is going to be attached to carbon number 3 is going to be included, and also even carbon number 4 as your back carbon, you must include the C5 and the C6. Same applies to this one. The only difference is that they're telling you where to look at which carbon, because they will be specific to you that looking at carbon number C3